Right. So we're going to talk about the sliding filament theory in this section, okay? And before I do that, I just want to go on about the banding that you see in a sarcomere, okay? A lot of the exam questions will focus on this banding, and they'll try to ask you to explain how that will change during contraction, all right? In essence, this is a sarcomere relaxed, okay, before contraction occurs. And these different colour bands are created when you have an electron microscope. Because the different colour bandings, the darker parts are the more dense parts, okay? And the density is in terms of how much protein fibres there are in there. So, the Z line represents the start and end of a sarcomere. And the Z line is where the actin, the thin protein filaments, emerge from. Okay? Then we have inside here the myosin filaments. The myosin filaments are held together by this M line, which is the central M for myosin section. Okay? The I band is the lighter band between the edges of two sarcomeres that is just made up of actin. The A band, as you can see, is the darker section that contains both actin and myosin. Although I hope you can see that there's a slightly lighter area where just myosin is present. Alright? So what I'm trying to get at is that the banding that you see in a myofibril is caused by the different concentrations of, concentration is probably the wrong word, but the different amounts of protein filaments that are in there. Okay? And whether there is just one, two, thicker or thinner. Alright? And that gives us these different colour ratios that we've got. Ratios is the wrong word again. Different colour transfers. Now, what I liked down here is this was trying to show a cross section through the muscle, and for you to try and represent, or to realise which bits represent which parts on this diagram. So if we can have a go at this together. Where is there just myosin? How do I know this is myosin, by the way?
It's darker.
Because it's darker, it's a thicker protein filament, right? Whereabouts would you find that on this diagram? Where there's just the presence of myosin?
In the H zone.
In the H zone, Bradley. So there, at this point in time, there is only myosin present. That's what it would look like as a cross section. What about this part here, where we have just got actin, the thin filament? Where would that be represented on the diagram?
I.
Where's that, Danny?
I.
In the I band. Good. That will just contain the actin, the thin filament. What about diagram A, where we've got actin and myosin? Where would we find that?
The A band.
In the A band. Now, a bit more specific, whereabouts in the A band?
M line.
Is it on the M line?
No.
No, it's the dark section where you've got both the protein.
Exactly. It's this very dark section that you can see in the banding of a sarcomere where we've got both actin and myosin filaments. Now, this leads me on to the sliding filament hypothesis or theory. And it is literally that all that happens to contract a muscle is these two sets of filament slide across each other. Right? And I hope you can see that by sliding across, you're going to change the length of the bands. The banding, the colours that you see, the darkness, will be different. Because there is a relaxed sarcomere, or two sarcomeres, and when they contract, the actin filaments slide over the myosin, creating a change in the banding. Okay, and I've got two diagrams to represent that. Actin sliding over the myosin for muscle contraction. And hopefully you can see that the two sarcomeres were this length and then become shorter at that length. Alright, and there's one diagram there. If I just remove that and try and show you a second way. I hope you can see how it affects the zones we talked about. Okay?